My name is Rick Claus, and we are here to talk about business continuity planning in a hybrid environment. And as I mentioned, if you're just coming in right now, I'm very surprised we have this many people in the room. It's the last session of the day here in Amsterdam, so thank you very much for sticking around. However, I'm rather biased. I like to think this is probably one of the most important sessions that are out there because disaster recovery is a rather important topic. Even if you have all your stuff inside of a cloud environment, if you have stuff in a hybrid environment or just all isolated inside of your own standalone data centers, they all have to be able to be kept up and working. And I'm assuming that everybody in the room here has or is responsible for assets in a data center somewhere. Is that a valid assumption? Yes, nod, this is interactive. Here we go, that's good. Because otherwise I don't know why you're here, but we're going to be learning about stuff we can do to make it easier. But we're going to talk a lot about theory behind it as well. I had a number of jobs over the years, literally started as the guy that jiggled the printer cable to get the printer to work about 27 odd years ago. Evolved through to becoming a LAN administrator, a WAN administrator, a large remote office, and then a large multinational offices environment from an IT perspective. And I'm wondering if there's anyone else here that's ever had to set up a DR site before. Put your hand up if you set up a DR site before. How fun is that? Like, picture taking your entire data center that's running 65 different workloads that are all critical to your operations and success of your business and having to duplicate them over 100 kilometers away somewhere or another country somewhere. And back in the day, it was blood, sweat, and tears just to be able to get a fraction of that to be able to work. And then IP connectivity over top of KVMs, and then being able to do data replication between SANs. It's a ugly and dangerous and scary business to be able to do it and then try to test it out. So we're here today to learn a bit about how we've made it a bit easier, but then also to reflect back on the stuff that you have to be aware of, because there's a lot of process and a lot of planning that have to go into getting ready for this before you can even start this one whole process. But for everyone that's in the room that said that they had done, they work in IT, they're responsible for data, they're responsible for assets inside of their data center. Again, hats off to you. I won't take my hat off because I'm bald. But the concept is that we are here and working in the world of IT because we have to eventually get around to the point that we're building these systems, we have to make them resilient, but we don't ever want them to fail, but we know that they will. So essentially, we're hoping for the best because we know it will eventually fail. And there will come a time, if it hasn't happened already, there will be some kind of catastrophic event that you will hopefully be prepared for so that there is minimal data loss, so that there is minimum downtime for the different workloads that would allow the systems to be able to come back up again someplace and then allow your organization to continue. But it is a dire world that we're faced with right now. Have you gone ahead and done the proper planning? Have you done the proper documentation? Better yet, did you test those backups? Did you test a failover to make sure things are good? Did you correctly identify the workloads that are going to be involved in all of this? So, comes down to a simple question. Are you actually ready for some level of a business disruption that will come at some point in time? And so the Forrester report from last year in July 2017 about the state of business and the state of IT resiliency came back and basically said the people that answered this particular survey, only 18% of them were really going to be feeling like they're confident and they're ready to recover all the data that they need out of their data center in the event of an actual site failure of a large scale or of a disaster. 18% of these global companies. Generally speaking, it's due to a level of immature planning that's there, out-of-date plans that have not been updated in ages since the first initial drills have taken place, or potentially absolutely limited testing all around. I kid you not, as a consultant, I went and I had a conversation years ago before joining Microsoft, talking to an individual, an IT manager, about what their plans were in the case that there happened to be a major catastrophic event. And he said, no problem, we got it covered. He turns around, grabs a red binder off from behind his desk, and I kid you not, blew the dust off of it for how to do business continuity in the case that there is a major disaster, plopped it down on the desk, and it says right there, we paid an undisclosed amount of money to be able to have some consultants come in and help us get this all working and all set up, and there it is, we're all set. I already knew we were gonna have a long conversation. So, out-of-date plans, limited testing come into play an awful lot. And then finally, it also comes down to compliance issues, come down to whether or not you can provide services after the service is up and working. Are you providing the right services? All these end up coming down to a competitive advantage that potentially your organization, your company is going to end up having over top of your competitors in that one space. If you're not in an environment where you have competitors, maybe you're a government agency, maybe you're providing different types of resources, it's still going to be the level of services you're going to be able to provide to those customers. Now, that's just the business leaders talking. Step back for a minute and think about you as individuals that work in the IT industry. Who's responsible for these different data centers and different systems? The impact of an outage is not just on that actual company. It potentially is going to end up skewing the perception of your entire industry and or your company inside of that industry if something happens to go wrong. Example of a software update or a data center fire that happened for a particular large airline in the States. It took down a massive data center. They had flights that were grounded for multiple days, missing millions upon millions of dollars because their planes were grounded, because their services could not work. It definitely damaged the brand of that particular company, but then it also damaged the brand of the individuals that are working inside of that data center and that are responsible for those kind of things, because it's personal skin in the game that's in there too. We too often end up being stuck inside of a reactive mode and not able to be moved towards a proactive mode to be able to work on these things. And so hopefully we'll be able to help you out a bit in that area, but it's still going to end up having you take a moment, reflect back on some things to see where you can go in and take a personal stake in making this a major focus inside of your organization, and also elevate the level of risk that exists as well, and mitigate that risk inside of your organization too. So again, this same Forrester discussion, they were talking about what are some things and some factors that you're concerned about. And so one of these things, example here, was general system failures. So we've all had hard drives that crash, motherboards that get fried, cooling systems that stop working inside of our own data centers and things along those lines. 56% of the time, it turned out, for this particular Forrester report, was the cause of system failures that cause outages inside of these different organizations. 38% of the time, it was due to power and power issues inside of those organizations as well. Redundant power not being present, or maybe even putting too much stuff inside of that data center without being aware of the auditing of the amount of power being consumed, and then having not enough backup power or generation power available to keep things running. Potentially natural disasters, 31% came into play. For as far as concerns came up, and then obviously a growing percentage, which is getting even larger, the concept of a malicious actor or some kind of a cyber attack that could have taken place, that could have done in there. Now, if you add up these different numbers, you've got close to almost 50% around natural disasters and cyber attack. That's going to be something that is potentially going to be less able to be planned for as a proactive measure, but you can put systems in place to protect you. But then also system failures and power failures, you should be able to mitigate those with more traditional ways of being able to think about this, with backups, with additional power, with planning for generation, that sort of stuff. So you do have the ability to tweak and prepare for most of these different criteria that come out of this. This was a disaster recovery discussion from 2016 from Forrester as well. Now, the issue we have these days is that for the most part, business really has become 24/7 as far as services are concerned. Our customers, our users who are consumers of these different services are expecting various different workloads to be available on a 24/7 basis all the time around the clock. You've got the issue of the amount of stuff that you have to go and protect growing on a regular basis. And having to also be accounted for in your disaster recovery plans as well. And then likewise as well, the number of machines, the pervasiveness of virtualization, the pervasiveness of IaaS options inside of public clouds also come into play. You also have to still back up and also plan for disaster recovery of services that are inside of major cloud providers like Microsoft Azure. So all this sort of stuff comes into play when you also start looking at those initial red book plans that I was talking about before. 85% of them said they actually had no plans that were ready for them to be able to go off and do things. 36% said that they were only willing to lose or only thinking that they could lose a day's worth of data, or lose more than a day's worth of data if things went down. And then 31% said, let's just go off and move to the cloud as a way of being able to solve all this. So business continuity is something that we've been thinking about for a while. There was a major hurricane that came through and hit the coast of North America on the eastern coast. It's unusual that it happened at that point in time. But it happened to hit just around New York City, where a massive chunk of companies' data centers happen to reside because it is so sheltered from these different types of storms. But this one storm of the century came in, and companies' data centers were 20 and 30 feet, working out on the metric, 3 feet, that's 6 meters of water. That's about right, isn't that right? 6 meters of water is good enough. I should know this, I'm Canadian, and I learned metric from the beginning. I've been living in the States too long. So having your data centers underwater is something that you definitely do not recover from very quickly to get your services back up and running again if it's on the same place. And the thing is that we actually knew this storm was coming. It doesn't move that fast. You watched it for days and days, coming closer and closer and closer and closer, and then finally the storm swell caught up with it and caused the massive flooding and massive outages. So I'm assuming, because there's only 1 or 2 people that actually got up to be able to go and catch their train, that this is an important topic to you. Let's try a little exercise. You all are responsible for assets inside of a data center. Think of the workloads that are running across all those different assets, okay? Now I want you to close your eyes and then draw a square inside of your mind. You have to close your eyes, pretend you're drawing a square inside your mind. Draw a line straight down the middle and then 2 across, so that you have 6 spots inside of your data center. Now, place your workloads inside of those 6 slots. Just work with me here. You've got some workloads randomly inside of those different 6 slots. And now roll a dice and pick a number, 3 for me. And which workloads just blew up because you had a fire in that particular rack? Do you have the level of preparedness to be able to recover from that random accident of one quadrant of your entire data center magically disappearing with no recourse for being able to get it back, except for your recovery plan, which may only be backups and restores? That's a pretty serious workload to have to come back from, pretty serious disaster to come back from. Now, what happens if the entire thing is gone to be able to get it up and working again? I think I've said enough. You can open your eyes again. Please don't fall asleep. So, business continuity basically has 3 chunks, 3 things that we have to talk about, and that you have to be concerned with during your planning for you to get this sort of stuff done. The very first thing is called resilience. How can I make my workloads more resilient to withstand a failure of some kind, so I don't have to go off and enact a massive plan for recovery potentially? Recovery is obviously the next one, where resilience fails on me and I have to go through and do a bigger job of restoring the functionality. So we have recovery options to have to worry about now. And then also finally, contingency plans have to come into play. So breaking these down, the first one with resilience, the business functions that basically are going to be supporting the infrastructure and has been designed and engineered so that things will basically continue to operate in case there happens to be this unknown event. We talk about this thing of a significant, unexpected event called a black swan. And it was curious to me as we developed this content where the term black swan came from. Anyone know the origin of the concept of black swan? Pretty quiet. The interesting thing about black swan is I did my research. I went to Google, typed it in, Bing, and typed it in. And basically, Black Swan, the concept of it was, besides the TV show, and besides the other event that's there, the movie that was there, It's actually that back in the Roman times, back in the early medieval times, after the Roman times, they basically had a literary element that was called a black swan, because they had the impossible thing that could never possibly happen would be a swan, which was always believed to be white. Actually, there was one that was black. And there was such an impossible event that it was used as an expression for literary terms for the fact that it's about as likely as a black swan being present. Well, the interesting thing is, as explorers and different people went around the world, they eventually discovered Australia. And in Australia backwoods, there actually is a swan family that actually is black. And so all of a sudden, these explorers came back to Europe, and there's like, we actually have black swans. So it's the unlikely event that would ever actually happen, but then they actually now found it. And then what's the next step of the modern day version of a black swan is the hindsight. Never could possibly happen. The banks and the institutions could never fail. And then in the mid-2000s or so, with all the banking industries, we had the world slowdown and or crash that took place. Unexpected, never going to happen, once-in-a-lifetime event. And then now, fast forward an additional 10 years beyond that, we all can now sit back as armchair quarterbacks and say, actually, we did see the things coming for this. So it's the hindsight, that's 2020, that's in there too. So that's where black swan come from. Do you have the resiliency to be able to handle a black swan once-in-a-lifetime event of a data center being 7 meters underwater or not for your entire workloads? Recovery, the next box comes down. Simply, how are you going to have your detailed processes available for you to be able to go off and recover from such a black swan type of an event, and ensuring that your critical business functions are already available for you as well? Do you have the detailed processes to make the less critical business functions available after the fact you've gotten the main ones back up and running again to get even more functionality available? And then finally, contingency. The fact that you potentially are going to come up with a way to kind of avoid and handle looking after the black swan events that might happen to come up, and also potentially like a last resort response to that particular activity happening. So throughout the entire day, if you've been following this hybrid track, 10, 20, 30, 40, and now 50, the concept of Tailwind Traders was this company that was going through an evolution of moving their stuff from on-premises to starting to using more Azure, starting to use more security functionality inside of Azure to make their environment more secure, starting to use network connectivity for hybrid, starting to go ahead and to use automation, and then also getting into governance and roles and policies that can go in and give people guide rails to be able to go off and use their Azure subscriptions. This is the last kind of stage to what you can do to improve your environment, and Tailwind Traders are basically facing this now too. What are they going to do? How are they going to leverage Azure to be able to go ahead and to come up with a level of business continuity to come into that process? So stepping back and looking at this, the very first part is coming up with your strategy. And so your strategy has to encompass a couple of different things. The first thing should be, when you're designing and working with different workloads, are you using and are you leveraging the existing high availability of those workloads on your on-premises environment? And are you using them effectively? So the idea is that when one server is disappeared, the second server is up and running. I'm assuming from an IT perspective, you can assume this to be something along the lines of a clustered database backend, so that one node goes down because of hardware failure, the other node simply takes over control, replays the logs that might have been missed, and then continues transacting along, maybe a little bit slower, then comes back up again, back up to full speed, as an example of using some level of high availability. Going in with a disaster recovery capability. So in case you actually you do not have the ability to have that level of high availability there, but you need to be able to still get business back up and working again, your traditional, I want to be able to go in and restore the content someplace else after a catastrophic failure is another option to make sure things keep on working. Backup and restore is the obvious way that we're going to get off and get started with this. As one method for how this works, I have to assume everybody backs up their systems. Please all nod your heads. Yes, we back up the systems. How about testing those backups? It's a standard question every person talking about backup always asks you. Yes, you test your backups, which is awesome. I'm also assuming that you have offsite storage for those backups someplace else. Yes, everyone has offsite storage, which is awesome. Probably moved away from magnetic tape, but now you're going for files. You ship those files someplace else. This is all an evolution of what's there. That's awesome for being able to get to that point. So keeping those in mind, let's take a look the next level deep for some planning aspects and some factors that you have to come up with. And this is where the human process of what's involved for disaster recovery and business continuity comes into play. This is where you have to be the ambassadors and the stewards of the data, and then talk with the business owners and talk with the different people inside your organization to be able to get this done. The first thing you have to come up and negotiate with is your RPOs and your RTOs. RPO stands for Recovery Point Objective. When something happens, what point am I able to bring back that particular workload or all of the workloads that's going to be satisfactory to all the different business stakeholders? Now, the answer you're going to get is probably immediate. I want the last minute back. I can't lose anything, which is highly unrealistic for the most part for all of those workloads. So you have to negotiate what those happens to be. The next one up is the RTO for a recovery time objective. Sure, I can get you back the last 5 minutes worth of work when it failed. However, it's going to take me 72 hours to do. That's probably not a good enough time objective for most organizations based on the workload, but maybe it would be okay for the system that's used to control the RFID cards door access to get inside the different buildings if you have to update something. But it's not acceptable for, if you're a retail organization, the sales terminal transactions and inventory management systems, which have to be up all the time. Otherwise, your company's not making money. You can extrapolate different examples based on your industry for what it happens to be. We all have different levels of time objectives for different workloads, and same thing with recovery point objectives with different workloads. Networking obviously comes into play as well. Networking is going to have to come up with, okay, where is it going to be? How are my customers and my users going to get access to that recovery area where this new built-up response happens to be? Is it redundant in the sense that I have multiple ways of getting there, multiple different carriers in case the construction happens to take out the main link that I happen to have in my data center? And then the last part is, I'm pretty sure you have more than just one workload you care about. I'm pretty sure you have to manage dozens of workloads, hundreds of workloads potentially. Think about that server sprawl. Think about those virtualized machines that are running these workloads potentially, even hardware-based machines too. How much has that grown over the years that you've had this role? Are you going to manually be able to go through that red book and go through the recovery procedures and do the restores for everything that goes on across all those machines in a timely fashion? And I apologize if I'm giving you anxiety and high blood pressure and everything else, but it's the reality is you have to bring in a level of automation to make this feasible because everything has grown so much, so fast, and so far. So backups and data stored for long-term retention as well can possibly also help with your recovery plans too. Again, example of an organization that happens to have been attacked by a particular virus that was brought in by a user, unbeknownst to them, that simply went through and did the good old-fashioned encryption across different servers and encryption of different workstations of their hard drives, and then locked down under ransomware to get that information back again. Are you able to bring back those different systems to different points in time when that particular malware didn't exist to prevent it? Because backing up isn't going to help you at that point in time. So we keep on talking about this term workloads, and you have multiple ones of them. It's something that is the next biggest thing that you have to do is cataloging them all. And I'm sure that you probably have some level of list of what's important because you work in the IT world, but it's good for you to review your list of workloads you want to protect with the different stakeholders, because your opinion of what's important is not necessarily the same as what those business owners is going to be. So you literally have to go through and identify who's got the critical workloads that are essential to be able to make sure that the organization keeps functioning, the company keeps making money, or the services keep on getting provided to those end users or to the public, whichever it happens to be. Those are going to be your business critical ones. Now, of that business critical one, are you able to go through and come up with an idea of where all the data is stored, what machines are being used to be able to serve that data up and serve up those applications, and what front-end devices or what client devices connect up to them for possible testing as well? And when was the last time that information that you just pulled out of your head as I'm talking about it was updated because of major changes that have taken place? Next level down is going to be talking about critical, but not necessarily time sensitive. So that's again, critical invoicing, critical sending out inventory updates, critical making sure people get paid. That's definitely important. Maybe not so critical, as I mentioned, something like an inventory that's run on a quarterly basis, or some kind of a report that goes off and pulls information from the door keypads. Those are particular. Not necessarily that critical or not that time sensitive, but you can get them back. You can negotiate different levels of point objectives and time objectives for these lesser ones to make it so you can focus on the critical ones instead. And then obviously the last ones are whichever ones that you can get to when you get to. Hopefully your systems are back up and running again for the lower level ones that are there. Generally systems that are not critical to any of the business's day-to-day operations, but definitely are still there when you need them to be able to do it. Your first level of steps to get into this is going to be talking about built-in resiliency. So I talked about this earlier. The example that I have is something simple like Azure Active Directory. I've been an Active Directory person for the last 18, 19 years now, and I love the fact you've got a multi-master model that allows you to have changes made on any one of those masters. They replicate without issue, knock on wood, with every other domain control that's out there, and things are just happy. You know when someone's locked out, you know when they change their password. That keeps things running because that's your identity, which is very, very critical and important. But then also, what about looking at more modern versions of other technology like SQL Server Always On, or other things from other vendors like Oracle RAC as an example for having continuity across that particular product for a data line. Using those technologies have a cost. They cost more. They require more hardware, they require more resiliency, but leveraging those as opposed to just having a single point of failure definitely is going to end up helping you out. And we had an earlier discussion today, if you're part of it, that was on the very first session with Thomas Maurer, talking about file sync and having file servers and moving content off of on-premises, storing the older, colder stuff up above someplace else, and also replicating it to different locations as a way of being able to do stuff just with your general file system, which could be considered a critical workload for some organizations. Now, backup is something that is obviously critical. We have a solution inside of Azure called Azure Backup. I'm going to be a little bit radical here and just say if you already have a comprehensive backup solution from one of our partners, continue to use it. I'm not advocating that you change. I'm just simply mentioning make sure you're leveraging all the functionality for what it can do. And so I'm going to be using the example of using Azure Backup for a bunch of different things for business continuity and for planning because it is obviously going to be critical for what we're going to be doing. With the concept of Azure Backup and using for any kind of a backup software, you have to go through, make sure it's deployed correctly. You're able to go off and back up across your different subscriptions inside of Azure, your different sites on your on-premises world. You're gonna have to go through and do backup for both your production, potentially your dev and test, it depends. You'll know that better than I will. But then also across multiple departments. It has to be secure. It then also has to make sure that you're doing data residency issues as far as where you're going to be storing that particular backup if you're using individual files. It's a good point to mention. Almost every single other backup provider out there today that's in the modern world is able to go off and simply store stuff at an off-site location. Some of those off-site locations can also be any of the cloud providers that are out there too. Make sure you investigate and take a look at that as an option. But from an Azure VM backup perspective, what we did is something as simple from an architecture perspective. You got a VM that is a collection of disks and a configuration file running on top of a hypervisor inside of an Azure cloud, as an example. It then is going to be going in and having access to the OS disk and also to the the data disks as well. We actually go through at the operating system, at the hypervisor and the fabric level. We make sure that we replicate that content in other locations inside of our data center in case we have a section of our region go down and your disks happen to be in one of those areas. We've got 2 other copies of it inside that same physical location, which is great. In this case, we've got a backup solution that's going to be going in here, and you simply go ahead and configure Azure VM backups. You can assign a policy that forces VM backups to take place in case you didn't know. We talk to a backup service, which is a combination of a bunch of configuration, including a storage environment as well. We identify a policy that's going to be involved with that particular backup. Once the policy's been created for an individual VM, back it up every 5 hours, take a snapshot of the disks, and then save it for X number of days as an example. That's part of the policy. The agent is going to go down and check and see, when it needs to go off and perform one of these particular backups according to policy, and then the backup is going to go ahead and initiate and start. We take a snapshot for a disk-consistent way of getting access to all the disks that are there. We have within the Windows environment, it's simply built in as far as volume shadow copy is concerned, and we keep on running and we're all good, so it's almost instantaneous for what we do. We then have that particular instant recovery snapshot available. Now, the interesting thing is we communicate that inside of our data centers through a secure connection to our storage area, otherwise known as our recovery services vault. But we also, if you encrypt your hard drives using disk encryption and key vault inside of Azure, we actually take a copy of the decryption at the same time so that the restore point that you use 7 months down the road after you've rotated your keys every 30 days or whichever it happens to be, the backup is stored with the proper keys so you don't have to worry about knowing where those keys happen to be able to unlock and work with those drives. Very important to know how that works. It's awesome. It works seamlessly. You basically go in, load the policy, configure it, and then fire and forget. It goes off and does it. You check the logs, and then you test it on a regular basis. This also works for Linux-based environments too. We're using a standard API call known as fsfreeze. Almost every single modern Linux distro supports fsfreeze. Simply a matter of going in and notifying that particular API that we're going to be doing looking for a disk-consistent state of those different disks. We have the ability to run a pre-script before we look. We also then can do an fsfreeze, grab those disks, and then we can run a postscript after the fact if we need to be able to get things up and running. Snapshot gets taken, the postscript takes place, and then we're now ready to go for an application-consistent backup on that particular thing. All these pre and post scripts are going to be unique to the workloads running on those Linux servers. We actually have a repository of pre and post scripts that people have worked with. Our team has helped create as well over the years for different workloads. As an example, my team was one of the ones that created the script for backing up an Oracle database on top of Azure. Yes, a Microsoft person helped write that script to make sure that it works using the proper tools. Now, I'm pretty sure that everybody in this room does not want to sit here for the next 27 minutes and watch a backup take place. Is that a correct assumption? So let's speed it up with the power of video and just show you the idea of what it's like to go off and do a backup and configuration. Inside the Azure portal, we simply have our storage recovery services that are there. You can make a brand new one. The reason why you'd make a brand new one is because you want to choose the location right down here at the bottom. Of course, you're not going to see this on the recorded view, but right there, the location is where the data will always reside and not move elsewhere, which is important for people that are sensitive as far as data sovereignty is concerned. We go ahead and look at an existing one as far as the Recovery Services Vault is concerned. And then under backup, we can take a look at the fact that this particular environment is already backing up some SQL Server databases on a managed instance of SQL inside of Azure. But then also, we need to go ahead and configure this to be able to go off and back up VMs. We don't have any VMs being backed up right now. So we're going to make a new policy. If you look here, we actually can do not just Azure machines, but also on-premises systems as well. So obviously, we are able to work in a hybrid environment back to the on-premises world. In this case, with on-premises, just to show you, obviously it works both with VMware, SQL Server, SharePoint, and also bare metal as well, as far as the agent being installed. We're obviously going to go through here and look at the steps coming up, but basically, you need to go off and you download an agent, you install it on the box in question, or potentially on the hypervisor for the VMware side of things to do the multiple systems that are there. You then go in and download a configuration file. The configuration file contains the security information that the client's going to use to talk to the backup service to get these commands, but then also to dump up its copy of the content of the backup. So that's how we work on a bare metal solution inside of your on-premises environment. So that part there is relatively simple from a step-through perspective. But we're actually going to go back and we're going to just use an Azure backup in this case to an Azure VM that currently exists. And here you can see obviously virtual machines. We also can do file shares and also SQL services as well as far as being in preview right now. We're just going to keep it with VMs. I just want to show you the last part here, which is simply the policy. The default policy or a custom policy. The custom policy, you've got all sorts of different options you can choose for how frequently you want to take disk snapshots, how long you want to keep them around for, how you want to age them out. This is what you use to develop your point objectives for what's available for those recoveries. And you get very, very granular if you want to, or you can just take the defaults, which this particular video is going to do, which simply says back it up on a regular daily at 5:30 in the morning to get it done. When that's done, you're going to go off and you're going to choose the different VMs that you want to go off and back up. And that's going to define the policy of back these guys up every day at 5:30 in the morning automatically and store this inside the vault. Pretty simple process to go off and set up a backup. You configure the policy, you identify the VMs, you now see the policy's been created, and then that particular box is now essentially now going to be protected and ready to go. Now, from a restore perspective, you have the ability to go through and restore individual files from those backups that take place at different time zones and different time snapshots. You can restore entire disks as well. You can also go back and restore all the disks or just partial some of the disks back to a brand new machine in case you need to do some investigative looking at that particular system. And you can even go through and do a replace disks if you wanted to with an in-place restore on a particular VM that's out there. And the concept of this is, again, you can go through and do an instant recovery snapshot backup like we just did, but then go ahead and swap those disks out in the back end. It's going to cause a redeploy of that particular box and then bring it up. So this is where the 27 minutes comes into play as far as what a recovery looks like. So this box is currently being backed up. It already has the policy set up to be able to go off and to hit a virtual machine. In this case, it is an Ubuntu box that's up and running. We can see that it is actually consistent and ready to go. So these are my objectives I can go through and do a restore on. We got a file system consistent backup that took place back on the 29th. I simply select it, hit the OK button, and then it's going to be asking me, hey, because you're choosing the option of doing a create a new virtual machine, what do you want to call this new box you're going to create off of these backup disks? I'm going to call it a clone as far as the last name is concerned, so I know it's not the same box and it's up and running. I want to do some more diagnostics on it. And then which storage account do you want to store this particular machine when you go off and do the restore of it. Once that's been created, the jobs get kicked off, and we can take a look at those jobs. And you can see here, a number of backup jobs has been configured, a backup has taken place. At the very top there, the restore process is basically in progress. Notice there, it's around 19 seconds since that started. And this is where we get the magic of video to say, fast forward 27 minutes or 25 minutes to complete that particular restore. And that machine has now been brought up with its entire configuration, all of its disks in a disk consistent state. It's a Linux box up and running now inside of my Azure subscription to be able to go off and to continue to investigate on or do whatever I need to do from a backup perspective. So integrated, same tools, can be scripted through a level of automation with PowerShell, can also have it done through the portal environment for individual machines. So it actually scales and continues to work. So we've got backup covered using existing tools. What about architecture? Architecting as far as high availability inside of Azure, things you should be aware of. The fact is, if you're designing a solution and you're just going to be doing it on a single VM, you should be aware of the fact that obviously we're only going to be giving you a 99.9% SLA for that particular VM in case something happens to go wrong with our data center and something needs to come back up again, or we do maintenance on it. We give you 99.9 with a single VM instance, and it's industry unique as far as how we do this. In order to do this, you obviously have to use a DS series machine, premium storage, and managed disks for us to give you this high level of availability. Next up is you do availability sets, which is basically defining at your application layer, your web front ends with a load balancer in front of it. You're going to have 2 web servers as an example, or 2 app layers talking to your backend database, whatever it happens to be. Those are put inside what's known as an availability set. Availability set means that we're going to deploy those 2 VMs inside of our region, and we're going to make sure that they're on separate areas, but still close enough proximity for performance. That is going to be on different power sections, different top of rack switches, and they'll also happen to be in different update domains if we have to do maintenance on the fabric, and different fault domains in case we have fault issues with power and as well. That's what an availability set is. We have a new functionality that we're now rolling out across our different regions called zones. And that's where we actually have multiple buildings that are separated by 30, 40, 60, 80 kilometers difference between those different buildings in a single region. Speed of light means that those systems are within 2 milliseconds of each other as far as network connectivity is concerned. We handle that. And then you can deploy machines into different zones in case one whole building happens to go down inside of a region. Very cool concept for how that works. And then finally, disaster recovery is where it comes down to having disaster recovery capabilities that I'll be showing you coming up next as far as combining automation, combining backup and restore, and combining synchronization on a regular basis for your different systems as well for doing a site recovery. So planning perspective-wise, we're going to have to take a look at understanding your concepts of doing some different types of deployments and making it available for physical locations where disaster recovery happens to be. We naturally go in and pair suggestions on disaster recovery that are still within inside of the same geographical area or region pairs as they're called. So for instance, Europe North and Europe West as an example for Amsterdam and Ireland, but then also in North America, East and West, North and South, East 2 and West 2. We build that into our design for how that works from a perspective of there. You are able to go off and leverage that if you want to as well. What about databases and database consistency across the board? Making sure that you have all the VMs that are part of that particular workload backed up. That's your intelligence that you bring with your tribal knowledge to this particular process, and then we give you the tools to make sure that they're all included. Governance-wise, this is something that, again, is one of those conversations you need to have with the different organizations, with whether or not you're going to have to incur additional costs, what those costs are going to be covered. Is it worthwhile covering those additional costs? Right now, as an example, for a ASR backup of a single VM, you're looking at street price of around $15 a VM. And then you don't get charged that until after you've done this for the first 30 days to see if it works to your needs. And then you say, yes, that's good. I want to protect these 65 different VMs for these different workloads. Those prices vary based on your licensing and all sorts of stuff like that. I'm not a salesperson. I don't know licensing. And then you need to go back also as well as where those different data resides. Is it going to be within inside of your jurisdiction? If it's within inside your data sovereignty, inside your country, and that sort of stuff as well. And then finally, once you got a plan in place, how can you optimize it? How can you get better with your time objectives and your point objectives for those critical workloads and how to be able to do it? So when you're doing this at cloud scale, you have to be visibly concerned with things like automation. Once you have manual steps that have to take place to do a restore of a critical workload, you're now placing the onus on an individual person to be able to competently do that under duress of a data center being 7 meters underwater, which is pretty stressful, and also making sure that they don't make any mistakes. So automation is going to help you make sure that you reduce the chances of human error, but you've put the human knowledge into that automation so that you know that it's actually going to go off and work because you've tested it. Likewise as well, you do not want to be responsible for trying to restore 100 VMs. Couple, no problem. 100 VMs, 1,000 VMs, without automation, I would definitely not be interested in trying to work that out with a time objective. There's no way you could possibly achieve it. Automation is key. Policy is something that is good as well, because as new machines come into play, they can automatically have policies for backup, automatically have policies available to make them so that they're ready to go to be included in your disaster recovery plan. You can also notice when someone comes out of policy for some reason as well. Reporting-wise, you get to know success or failures of tests. Did it work? Did it not work? Different levels of time it takes to be able to go off and achieve those different objectives. And then finally as well, that automation also applies to the automation of different scripts and the order in which things have to take place as well. So Azure Site Recovery is the tool we're going to be introducing and using to be able to do this. Azure Site Recovery leverages the automation, leverages the backup, but then it provides a whole level of knowledge of being able to come up with disaster recovery solutions along with it that you can now leverage to be able to do it. The neat thing as well is that Azure Site Recovery is not exclusively that you have to go off and use Azure as your location, you can actually go off and use it for physical data centers too if you wanted to. But ideally, you're going to look at having to move your things up inside of an Azure environment, and then if needed, brought back down again when you got your data center happy and working again, got that 7 meters of water pumped out and everything dry. Or you can actually just leave it inside of Azure and consider it like a migration, and you're not running it inside of migration. So generally speaking, rather than renting a physical DR site, we're going to go off with this particular example here, and we're simply going to use an Azure site to be able to go off and to do a recovery. So in this case, the idea is that Azure Site Recovery is something that works with a VMware-based machine on premises with multiple VMs hosted on top of it. It works with Hyper-V as far as the hypervisor is concerned, and it works with physical machines to be able to replicate data up inside of Azure. And it's able to store data locally to be able to go up in batches so you don't have all these machines talking in a secure fashion up into Azure. It also works obviously on Windows machines, but it also works just as well on Linux-based machines as well. And you can even go through, if you needed to be able to go and put it inside of any cloud, because it's another destination, or obviously Azure is the preferred place where we're going with this one. And then finally, it also works between Azure regions as well, in case you need to protect yourself in the event of an actual region failure. Now, planning is something that is critically important. And again, it's a lot of effort to be able to go through and collect how many systems are involved in those workloads. How has it grown over the years to add new systems to those different workloads? What networks are they using? How much bandwidth is it using? How much data is changing? And so we've actually made a tool for you to be able to go off and to collect this. This is a free downloadable tool that's linked during the process of setting up Azure Site Recovery. And the idea is that you're going to be going in and running this against a physical box, or you're going to go in and run this against a hypervisor that has those different systems that are on it. Currently, it's working with VMware. Obviously, we've got it coming out the door, if it's not already by the time you view this video online, that it's also going to be working at an exceptional level for Hyper-V as well, for Hyper-V-based hosts. But it's going to go through and check the number of disks, the disk size, how many IOPS are going to those different disks, how much churn is going through those different systems, how it's going to be booting for that particular system if it's a physical box, and then also what versions of the operating system. All that gets collected up. It also will go through and check your bandwidth and check to determine how much traffic is happening between those different systems. The type of throughput is going to be required for you to support replication up into Azure. The number of VMs you're going to batch together to try to reduce that bandwidth. That gives you suggestions on what this has to be. It even is able to go through and determine your infrastructure requirements. What size of VMs should you be using up inside of Azure? How much will those different VMs actually cost you to be able to run inside of Azure for periods of time? So this contains golden information about those different workloads that you can use to come up with an assessment for what's going on for your planning for Azure Site Recovery. And then finally, obviously, how many servers you have to go with and how this goes. So we're going to be using the same technology of time warp because this particular example was a 3-tiered application running on premises inside of a Hyper-V environment. And it also happens to take about 27 hours to go through a single synchronization of all 3 machines inside of Azure. So I don't want to put you through a 27-hour demo. We're going to go off and have a recovery service vault that's going to be created. This is, again, data sovereignty for where this particular data will be stored, giving it a name for the resource group where we're going to store this particular recovery area. And then choose your location as far as data sovereignty is concerned. In this case, we got Southeast Asia. Next up with that recovery vault, we're now going to go in like we did before, but instead of choosing backup, we're going to be choosing the option for doing a site recovery, which requires some additional steps. The good thing is that we give you those steps on the right-hand side. You're going to go through it. The very first one's preparing your infrastructure. And it's going to be asking you, hey, by the way, as I back up and do the wrong thing for my video, come back on again for where we were. And this is where it becomes challenging to fast forward that video back to where we were. So hang on a second while I get it. There's preparing the infrastructure. There we go. We're going to be backing up the machines. In this case, it could be on premises because it's a Hyper-V box that we're working with. And then you also could obviously use Hyper-V or vSphere or any of the other ones that happen to be listed. And then in this case, it's asking us, do we have VMM involved that's there? Now, this is an important question to ask. Did you do your planning? Yes or no? What did I suggest that you all do? Do your planning. Run the planning assessment tool. I have yet to confirm with the engineering team if they actually track the way that you answer this, and then when you call for tech support, if they deny you tech support, that's a joke. It's really just a reminder, the human aspect of did you do your planning to be able to do this, because you're going to be involving of that. So yes, let's all say that we have done our planning for this particular demo, and we'll go ahead to continue. And then coming up here, let's prepare the source. Now in this case, we basically have to do, we're doing Hyper-V. You have to identify the clusters of Hyper-V servers that have clusters of VMs on top of them and define them as a site. And the site is going to simply be a gathering of the different Hyper-V machines that are running these different VMs. In this case, for this demo, we only have one Hyper-V site and one Hyper-V server that we're going to simply put in here. So we call it a site, simply a collection or grouping. We then have to go in, and it now looks for registered servers. So that means we have to go off and install some software on those Hyper-V servers that are running to be able to go off and to get things registered correctly inside of the recovery vault. So here we give you a step-by-step process of what has to happen. The first one is install the agent down on that particular Hyper-V box. So we just simply go off and download that. It's 51 megs. It installs to the individual Hyper-V server, and that gives it access to all the data that the Hyper-V hypervisor understands. The next thing is the key vault registration. So this is the best part. You don't have to remember some kind of long SAS URL or some kind of long token or some kind of long password to be able to know which recovery vault this backup is going to be going to and the ASR service is going to use. We have that inside of a configuration file. You download that to the box and you're ready to go. So those two files are now downloaded and we're ready to go to be able to use it. This happens to be the Hyper-V box using that we're doing the demo from. You can see here we've got our 3 machines, 3-tier application, a Windows box, a logic tier, a data tier, and then an application server that's a Linux box running Ubuntu that are available to back up. In this case, for the purposes of the demo, we actually choose to go with all 3 of those plus the Ubuntu server. We're installing the software for the agent on the hypervisor. We go ahead and say register. It's now going to ask us for that configuration file that we downloaded that's unique to that particular recovery vault. It pre-populates the fields. We then go ahead and say next, and then connect directly up to that individual box for a recovery site server to be able to do your backup and do your recovery services. You could, if you wanted to, have one box locally that every other box talks to, other hypervisors, to batch your data together to make things more effective. That's why I was asking that point. This can take 15 to 30 minutes for it to register. Fast forward in time, it's now registered and we can see that individual server from those drop-down lists, which is awesome. We have to choose a storage account that's going to be used. So we're going to create one for this particular recovery test. We then have to go off and create a network that we want to have the recovery machines deploy into that's isolated from the rest of the networks so that we don't impact any other workstation or workloads that are running inside of Azure. So now it's been created from a drop-down box, obviously choosing your subscription. You see the subscription being used, the storage account, and also the network that's being used. And then now we go in with our policy to be able to determine how often this particular system is going to be backed up and which ones are going to be involved with this particular policy. So we just give it a name, and then we choose from a ASR recovery process. We want to go off and choose a copy frequency of 5 minutes worth of data for our intervals, and then we're going to want to choose a recovery point of 5 minutes, and then look for application consistent backups. It makes that policy, stores it inside the vault, and then gets ready to go. So we have our targets, we know where we're going, we know our settings, and we know our applications as well. Now we actually go through here when we select which boxes are we going to go off and back up. So we're doing on-premises, we choose our location, we're then able to go through and choose our subscription, choose the resource group we want these items to go into. We choose the network, the storage account we want the data to be stored in when they get recreated and backed up. And then also go through and choose the network that they're going to be attached into from a drop-down list that we already pre-created. And then finally, choosing the subnet. And then let's go through and check which machines we want to bring back. Well, these are the options that we had from our backup. Let's make sure that we're choosing the 3 servers, and as well, we're going to choose just the infrastructure file server as well, just to show you that it can be included with the backup, but not necessarily brought back with our tests. So you have to identify what operating system each machine is running, so it knows which agents to use. In this case, Windows and Linux have to be correctly selected. And then because we are using these different systems as well, we have to identify which disk is the OS disk in question. Now, for the application server and the logic server, and the data server, they're all simply a single disk, but the file server actually has multiple disks, so we have to select the right one to identify which is the OS disk. As you can see, this is basically pre-populating a lot of stuff that would be required in a level of automation that's going to be coming up in just a bit. So it gives you a default replication policy for let's go off and replicate these systems up into Azure. Let's go get them started. This is in addition to a regular backup process that you would have. In this case, we're saying 5-minute intervals. We're going to do a recovery point retention of 5 hours. We're going to have an application consistent backup, and we want to go ahead and start this immediately. Go ahead and enable that replication. This is where all the final pieces come into play, tell you that the jobs are active, and then this is where you have to go off and fall asleep and come back in 24 hours for this to finish, just for this one demo. This is a long video to explain a 24-hour process to be able to go off and set this up for an application-consistent disaster recovery test. But we come back here, we can see that the recovery plan can now be created because the backup is now done. So my recovery plan and test to bring back this one workload is only going to involve the logic tier, the web tier, and the data tier. It's not going to involve the file server. So I only check those 3. This is my big red book that I'm basically now creating based on all the information it now knows about those 3 systems. So inside that recovery plan, I can now go in and edit that recovery plan to say, let's bring this up. In a 3-tiered application, you have to be concerned that the database comes up first, then the web server comes up, then the logic layer comes up too. So you're able to do that by these things called groups. You can see here, I've got them all inside of one group. They're all going to start simultaneously. Not a good idea. I need to break them out into the proper order, so I just make multiple groups. With each one of these different groups, you're able to also associate scripts and steps for automation as well. So this guy's going to go through, make it a couple extra groups, move those machines into the proper groups, and then go ahead and save this individual plan. And we're going to show you an example of a post-activity script. In this case, it's a manual step that simply says update the DNS because it was just a simple demo. So it's going to go off and say, make sure when this runs, there's a step that is a manual stopping point that says go and update the DNS systems that are there. So this plan has now been made and is now ready to go. The neat thing is, because the data has already been replicated, we can go ahead and start a test option of making sure this works. And the test option is something you can run as many times as you want against this particular recovery plan. And that's going to go ahead and do all the steps that it would do and actually deploy the systems and make sure they're consistent and start them up in the proper order. And you can see them now all go ahead and run and start to do this recovery and bring these different machines up. Fast forward again about 30 minutes for this particular demo to be able to now see that they were all successful and now all finished for doing their restoration. And now back inside of the regular Azure environment, I can go back and take a look at these 3 different systems and now see I've got a new resource group, I've got 3 systems that are based on the replicated and synchronized data, and I can go through and done some additional manual tests against them to make sure my workload is now working correctly. And then finally, when I'm done doing all my tests, I can go back into my plan, and the most important part is clean up the test failover. I don't want to pay for those systems. I know it's working. Just let the replication continue. The neat thing is you literally can go with your Azure subscription right now today, and you can do this. Replicate the data, define your policies, check out the actual application, see if it synchronizes, do your test failovers for some sample workloads immediately after leaving the session. You don't get charged for the use of ASR until after 30 days of you going off and trying it out. And then you're able to go off and deploy, run a test. It didn't quite work. I need to work on my automation. Fix that automation, clean it up, try it again, and see how that works. That's basically the concept of how ASR is going to go off and deploy. You have some log notes, and then that's going to be saved to that individual system. So ASR and disaster recovery is a large process involving a lot of planning, a lot of discussion with different business stakeholders and partners to understand what's involved with recovering your individual sites and planning which workloads to go off and to protect. I cannot stress the importance of going through and trying this automation, trying the drill, see how it works. The best part is it's all automated. The cleanup was the last step I didn't show you to the final finish, which was simply clean this up. It deletes all those resources and simply no longer is charging your Azure account at all for the compute, networking, and storage of those particular boxes. So fantastic. And with that, we're at the end of this particular session. You've been through disaster recovery using Azure Site Recovery. You've seen it work with a 3-tiered application of mixed Windows and Linux boxes, and you've gone ahead and watched that replication take place over a massive 27 hours in this time frame of about 9.5 minutes. This information is something you can go off and try yourself. If you don't want to use your production environment, we have a lab you can go through from Microsoft.com/learn that is called ASR Labs. Documentation-wise, we're very good at the docs that are involved with this particular environment with ASR Docs for ASR Docs Online. And then generally speaking, what I would suggest for you is quite simply, go forth, remember you're supposed to do your planning, run the assessment tool beforehand, and then give this a shot as far as your ASR environments and try this out inside your Azure environment as well. This is the last session of the day. There's no other sessions to go to. I want to thank you very much for sticking with me for so long. I'm about 1.5 minutes, 2 minutes over. I apologize for that. Thank you very much for staying with me. I appreciate it. If you enjoyed this session, my name is Rick Claus. If you didn't enjoy the session, my name is Thomas Maurer.